Hello friends, let's decompose this rational expression using partial fraction. So this is a rational expression. Basically, I just want to decompose it into sum of simpler terms, right? Just a sum of simpler terms. That's basically what I want to do. Now, observe that the denominator, right? The denominator is a product of distinct linear terms. So the linear terms in the denominator are x minus 1 and x minus 2. They are distinct, they are different, right? So if you want to decompose a rational expression like this, the way you do it is that this is going to be equal to, so you have something over the first linear term, which is x minus 1, plus something over the second linear terms, which is x minus 2. Now, because this is a linear term, what is going to be on the numerator is going to be a constant because it's a linear term. And on the other one is also going to be a constant, that is an expression without x. So I'm going to write b here. That's a constant, right? Now, we want to find a and b. How can we find that? Okay, so I'm going to erase this. If you observe that this expression, this whole expression here, is not defined when x is equal to 1 and when x is equal to 2. How do I mean? If I plug in x equals 1 in this expression, so let me just plug in x is equal to 1, 2, 1, and then I have 1 minus 1, and then I have 1 minus 2. This is just going to be 2 over 0 times negative 1. This is going to be 2 over 0. So since I have 0 in the denominator, the expression is not defined at x is equal to 1, since I have 0 in the denominator. The same thing applies to 2. If I plug in 2 into the expression, so I have 2, then 2 minus 1, 2 minus 2, I'm going to get 4 over 0. So I have 0 in the denominator again. So the expression is not defined at x is equal to 1 and at x is equal to 2, as we've seen here. So why do I need that? So I need that to be able to kind of decompose this this rational expression. So what I'm going to do is that for this, to find my a, right, since this expression here is not defined, if I plug in 1 there, I'm going to get 0. So I'm going to plug in 1 into this part, right, except that part, except this one that is not defined. I'm going to exclude the 1, because if I plug in 1 there, I'm going to get 0. So I'm going to plug in 1 into the other part, right? You know, I'm going to plug in 1 into the other part. So I have, to get my a, I'm going to just plug in 1. Then this is just going to be 1 minus 2. This is going to be 2 over negative 1. This is negative 2. That's my a. Now, you can guess how I can find my b, right? So to find b, right? To find b, this whole expression here is not defined at 2, because if I plug in 2 into that, if I plug in 2 into this, I'm going to get 0. So now I will come to my original expression, right? I will come to my original expression and I'm going to plug in 2 into the other part, just this part, right? I'm going to plug into, that's going to be my b. So my b is just going to be, I'm going to plug in 2 into that. So I have 2 minus 1. This is going to be 4 over 1. This is 4, right? So I found my a and my b. So all I have to do is to just just plug everything in. So I have going to copy this. Sorry. So this is just going to be 2x over x minus 1, x minus 2 equals negative 2 over x minus 1 plus 4 over x minus 2. And that's going to be the decomposition of that rational expression. Yeah, hope this helps.